Okay. In our last problem, we were given some parametric equations, and we had to plot the points and make a line. In this problem, we're going to be given 2 points, and that's enough to determine a line, and we're asked to write the parametric equations that form that line. It's a little bit trickier because there's actually many different answers that you could, there's an infinite number of correct answers to this. And I'm going to show you 3 different correct answers to kind of, get you thinking about why that's the case. Okay? So here, our points we're going to pick are 2, -3, and 10, 1. So the first thing I'm going to do is I'm just going to make a table. And I've got t, x, and y. And I'm trying to give myself lots of space here. And the first thing about this is that I can, what makes them different? What makes it possible for so many different answers is that I can pick what values I want for t. So I've got, let's see, 2, -3, and I have 10, 1. So if I'm picking different values for t, and if you want to think about this in terms of that like moving particle thing, it's me deciding at what time the particle reaches different points. I can decide when the particle reaches the point 2, -3, and when the particle reaches the point 10, 1. I can pick anything I want. The only difference between one equation and the next will be kind of how quickly the particle moves. So let's pick some easy numbers. Let's say that at time 0, we're at the point 2, -3, and that at time 1, we're at the point 10, 1. So let's go write our equations. So we can think of this as 2 separate equation writing exercises. Right, so we're writing an equation with 0 to 2 and 1 to 10. So first of all, we're going to look at our rate of change of x with respect to t. So that's +8 and +1. So x changes 8 units for every 1 unit of change in t, which means that our x output will be something 8t. Okay? But it's not, that's not going to work necessarily because 0 times 8 is not 2, it's 0. And 0 times 1 is not 10, it's 8. So a couple different ways that we can do this. We can assume that there is some sort of thing being added on. That's going to be the case. And then we just have to enter one of our xt pairs and kind of figure out what that b is. So let's go ahead and do that. So let's see. So we'll enter 2 equals 8 times 0 plus our unknown b, which makes 2 equal to b. And so our equation is x equals 8t plus 2. You should always test out your equation, but it'll work. So let's go for the y side. Our increase here is +4. And so that's an increase of 4 units, a y increase of 4 units for every 1 unit of increase in t, which means that our formula will be y equals 4t, but then it's going to be plus or minus something. To figure out what that something is, we'll plug in -3 for y and 0 for t, and we end up with -3 equals b, and so our equation is y equals 4t minus 3. Which kind of makes sense here. We're starting at 2 and adding 8 for every new unit of time. Starting at 2 plus 8 plus 8 plus 8. That's how our x-coordinates are changing. Our y-coordinates start at -3, and they increase by 4 for every new unit of time. So 4t. But we could have picked differently. All right, for example, let's go up here. I'm just going to pick some different equations. I could have said t, x, y. Now put our points in again. 2, -3, and 10, 1. Now our change in x is still +8, and our change in y is still +4. Let's pick different t values. Let's say that t reaches this point, or the particle reaches this point at time equal to, I don't know, 5. And then let's say it reaches this at 6. Okay? So we're here after 5 seconds and here after 6 seconds. So our change in t is still +1. So our formula will be, we have x equals, remember it's 8 to 1, so it's still going to be 8t plus our unknown number, our b number here. We have to add or subtract to make this work, because 8 times 5 is 40, not 2. So we'll put in 2 for x. So we're going to just fill in the x and the t. 8 times 5 plus b. 8 times 5 is 40. Subtract 40 from each side, and we get 38 equals b. If you happen to recognize this, this is the same thing we would do if we were finding the y equals mx plus b form of a line given 2 points. All right, we would find the slope, we plug the slope in, and then we solve for b. Same thing here, except instead of x and y, we're looking at t and x, and we'll look at t and y separately. So our equation in the end is x equals 8t, well, that should be a -38, right? -38. And then for our y equals, so it's still going to be 4t plus our unknown b, something we have to, an adjuster number there. So we plug in -3 for y. So again, we're just going to plug in the y value and the t value that we have, and we'll figure out what b is. So this is equal to 4 times 5, that's the corresponding t value that goes with this point, plus b. 4 times 5 is 20, and -3 minus 20 is -27. Wait, what did I just do? 4 times 5 is 20. Yeah. -23. Jeez. Losing my mind here. Okay. So then, our equation is y equals 4t minus 23. Okay. So the procedure here, if I'm given 2 points and I'm trying to write the equation is, I would pick 2 numbers for t. Like I could pick 5 and 6, or I could pick 0 and 1. Then I want to find the slope. So that's the rate of change of x with respect to t. So it's whatever our change in x is over change in t. That becomes the coefficient of t in our equation. And then it's going to be plus or minus some constant term beyond that. So to figure out what that constant term is, we just plug in the t and the x, a t and an x value that correspond, like 5 and 2. I could have picked 10 and 6, would have got the same answer. And then we solve for b, and we can drop that into our equation down here. And this is exactly the same thing we would be doing if this were a y equals mx plus b equation from 2 points. So if you want to look up a separate video on that, you go ahead. Except instead of being x and y, we've got t and x. That's it. One thing here is I could, and there's all sorts of other things that I could do. I just want to point this out. I could go in reverse. I don't have to pick this point first and go, we're kind of imagining that the particle is moving from left to right. That doesn't have to be the case. We could go the other direction, right to left. I could have picked 1 and 0, or 6 and 5. I could have reversed the coordinates, or reversed the direction of the t values there. And I don't have to pick t values that are 1 unit apart either. I could have picked t values that are much further apart, or much closer together, say, or further apart. You mean further apart, or closer together, whatever. Let me show you an example so I can clarify. If you notice, this line here passes through several whole number points right here. And I'm going to call this t equals 0, 1, 2, 3, and 4 out here. So in our new table, I have t, I have x, and I have y. T at 0, we're at 2, negative 3, but now t is at 4 for 10 and 1. And here, this is still plus 8, and this is still plus 4, but now t is increasing by 4. So our rate of change of x with respect to t is now 8 to 4. So we increase 8 units on the x-axis for every 4 units of time. And here, we've got an increase of 4 units on the y-axis for every 4 units of time. So our new equations would be x equals 8 over 4, which I could simplify, but I'm just going to leave it as is for now. 8 over 4t plus 2. And because we kind of know that it's going to be plus 2 because we know where the 0 t is. It's at x equals 2. So we don't have to really go through that process of, all that we did down here if we know where the 0 is. Now, for y, it's going to be 4. So the rate of change of y is 4 units of increase on the y-axis for every 4 units of time. So that's going to be 4 over 4 t minus 3. And I want to point out, you'll notice if we go down here, our original equation was, when I just did 0 to 1, was 8t plus 2. Now it's 8 over 4t plus 2. And here was 4t minus 3. Now it's 4 over 4t minus 3. So by kind of stretching out, the t value, taking it from 1 to 4, I just kind of made a slight alteration in the equation over here. But they still have, I would simplify these obviously, but we still have the 8 and the 4. So the slope of that line is still, you can still find it in the equations. Of course, those are changed to 2 to 1. All right, that'd be 2t and 1t, and you'll notice 2, 1, 2, 1, 2, 1, 2, 1, as opposed to 8 and 4, which was 8 all the way over and up 4. Okay. So the coefficients of t in the two equations still describe the slope, just in a different way.